Hi guys, it's Mrs. Huff and we're starting our first official lesson. So this is Algebra 1B. And in Algebra 1B we do chapter 5, 6, and 7. So we're starting in on chapter 5 and we're going to be working on section 5.1 today. And so this chapter is all about properties of exponents. So you're going to see exponents and stuff. Now, the nice thing about this is you'll be able to pause this video and whenever you need to, you'll be able to rewind, go back if there's something you didn't understand and watch it again. You'll want to make sure you have a notebook or some paper and a pencil handy. And if you have trouble getting those supplies, let me know and I can help you out. My phone number is 810-640-5499 and you can call or text me on that number. That goes right to my cell phone, and I'll help you out with anything you need. Just try to not make it like crazy hours of the night. Obviously I do sleep, so but you can reach out to me anytime you need to and I can help you with this stuff. So we're going to get started. We're going to jump right into section 5.1, and that is all about properties of different powers. Okay, so we're going to do product of a power, power of a power, power of a product, and as you can see, there's a lot of P words and you're going to get really confused on the terminology. So I'm going to make it very simple. We're not going to worry about the terminology. We're just going to see what happens with different examples. So the first thing you need to know is the difference with a base and a power. So the base is the big number, okay, size-wise, okay, not the larger number of 2, but the bigger number size. And so these both have the same base. So when they have the same base, the bases are the same, you keep the base, okay? The other number is the exponent, okay? We call this the 3 is the exponent. We also can say that when it's to the third power, we can say power or we can say cubed even, okay? This is the 5th power, okay? So these powers or these exponents, we're going to add them. Okay, I like to put a little plus there so I know. So 3 plus 5 is 8. And so now you just leave it as 7 to the 8th power. 7 to the 8th power is 7 times 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 7, 8 times. And if you can imagine, that number is going to be really, really large. So there's no reason to try to figure it out using our calculator. Okay, we're just going to leave it as 7 to the 8th power. It is not 7 times 8. Okay, it is not 56. It's a very much bigger number than that. So we want to just leave it as 7 to the 8th power. And that's how it would look on your worksheets. And it's also going to look like that on the test. So let's look at another one. 999. All the bases are the same. We keep the base and we add the exponents. Okay, but there's no exponent here. So what imaginary number do you think goes there? Yep, it's a 1. Okay, so you can add the imaginary 1 in and you're going to add the exponents. 1 plus 8 is 9, and then 2 more is 11. So it's 9 to the 11th power. It works the same way when you have negatives. Just remember, when the negatives are wrapped in parentheses, you keep the -5 wrapped in parentheses. Okay, and then again, it's missing the 1 here. So 1 plus 6 is 7. Okay, I don't think you can see. Let me turn that a little bit so you can see that. Okay, the next one, it works the same way with letters. When the bases are the same, even though the base is a letter, it works the same way. And we add the exponents. 4 plus 3 is 7. So now I'll move it down so you can see a little bit better. Now I have 4 examples for you. I want you to pause the video at this point, write down these 4 examples, try them on your own, and then, check your answers with me. But first, pause it right now and try them on your own. Okay, so I'll give you a second to write them down. And at this point, you're going to want to pause the video so you're not going to surprise yourself with the answers. I really want you to try these on your own first and then see if you did it correctly by checking your work with mine. Okay, so bases are the same. We keep the 3 and we add the exponents. 2 plus 7 is 9. Bases are the same. We keep the base and it's missing a 1 here. 1 plus 9 is 10. It works the same way with negatives. We're going to keep it wrapped in a parenthesis, though, anytime we have negatives. That was my whiteboard cleaner, sorry. And then we're going to add 2 plus 1 that's missing is 3. And it works the same way with letters. X, X, X. The base is the same. We're going to keep it an X. I'll push it down a little bit so you can see. And 2 plus 6 plus that imaginary 1. So 2 plus 6 is 8. Another one is 9. So that is how you do those. Okay? Hopefully that was easy enough. So that's the first property. I'm going to try to pause this and see if that will work, if I can pause. Okay, I hope that paused correctly. So I have the next group of problems up here now. And now we're going to do power of a power. So power of a power is when you have a power and another power on top. So power to a power. So there's a power of 5. This is the 5th power. But the 2 is to the 5th power, but it's also to the 3rd power. So when we have power to a power like this, we're not going to add, we're going to multiply. Okay, so 3, and I put a little dot there for multiplication. 3 times 5 or 5 times 3, doesn't matter. So you keep the base the same, and 5 times 3 is 15. We're going to leave it as 2 to the 15th power because 2 times 2 times 2 times 2, 15 times is going to be a huge number, and we don't need to mess around with that. We can just leave it as 2 to the 15th power. When you have a negative, remember you just keep the base wrapped in those parentheses. So the negative 6 stays wrapped in those parentheses, and power to a power we multiply. So a dot here. 2 times 5 is 10. Works the same way with letters. The base is an X. We keep the base. And power to a power we multiply. 2 times 4 is 8. It's super simple. Power to a power, you just multiply. So this time you're going to want to pause the video and write down these 3 checkpoints and try them on your own. Once you're done, go back and play the video, and I'll go over the answers for you, and you can kind of check your answers at that time. If you have anything wrong, just fix it. And remember, you'll be able to use all of these notes on your tests because everything's going to be open, basically open notes when you go to take your test in a couple weeks. So make sure you're keeping good track of stuff. And the best way is probably to keep it in a binder so it's all organized for you. At this time, go ahead and pause it. And then go ahead and try those problems. So we have the 4, we keep the 4 of a base, and 2 times 7, power to a power, is 14. Again, the negative has to stay wrapped in the parentheses, so the negative 2 stays wrapped, and 4 times 5 is 20. And it works the same way with letters. We keep the base of n the same, and 3 times 6 is 18. And that's it. That's all you're doing. Power to a power, you multiply. I'm going to pause it, and we're going to get on to the next section. Okay, so now we're on the next property, and that is going to be power of a product. Okay, so now we have a product, meaning multiplying. So we have 2 numbers multiplying together, and we have a power on both of them. So this is kind of like the opposite of the distributive property. If this 8 was out in front of the parenthesis, we would do 8 times 24 and 8 times 13. But now it's on the outside, so we're going to take that 8 and we're going to kind of like distribute it to both things. Super easy. You're just going to do 24 to the 8th power times 13 to the 8th power. That's it. Okay, we don't have to do 24 times 24 times 24 8 times, or 13 times 13 times 13 8 times. Those are going to be huge numbers. And then if we actually multiplied them together on top of it, it would be even bigger. Okay, we don't need to worry about that. That is all you need to know. Okay, and that's going to be helpful later on when we try to put all of the properties together for letter C in a second. It works the same way with letters and numbers. So this 9 gets the 2. the x gets the 2, and the y gets the 2. So anytime you have a power outside of the parenthesis, you need to give it to everything. You need to distribute it to everything. So the 9 gets the 2, the x gets the 2, and the y gets the 2. Now, x to the second power and y to the second power, those are done. Those letters are done. But when you have a number like this one's easy, okay? 24 to the 8th power, that's going to be a really big number, and I can't do that in my head. But 9 to the second power, I can do that, okay? It's 9 times 9 twice. Not 9 times 2, not 18, but 9 times 9. It's 81. So we can actually go one step further on this one, and we can make this 81. So we'll have 81 x squared y squared. Both of them are correct. I'll turn it so you can see. Both of them are correct. But when you have something simple like this, you might as well condense it down and make it even more simple. So we're actually even simplifying it further. It's kind of like everybody knows that 2/4 is the same as 1/2, but we always reduce it down to 1/2. It's the same thing. Okay? And the last one is putting all of our properties together. I like this one best because you really have to remember all the different properties. When do I add and when do I multiply? So the first thing I notice is there's a 2. It's kind of like this 2 up here. The 2 has to go to both the x and the 2 here. So 2 to the second power. And the x is also going to get the 2, but I run into a problem. I have 2 and 3. I have power to a power. What do you do with power to a power? You multiply. So you're multiplying the 2 times 3. So you keep the base of x, and 2 times 3 is 6. This 2 didn't have an exponent, so if we wanted, we could have put the imaginary 1 in there, but what's 2 times 1? It's just 2. So that's why it stays a 2 there, and it becomes a 6 here. Now we're ready to just finish out our problems. We're just going to write the x to the 4th here. We didn't do anything with that. We're just rewriting it straight down so that we can work with it more. Because now I see something else. Now I see a couple things that I can clean up. First of all, this is easy. 2 to the second power. 2 times 2. Twice. That's it. 2 times 2 is 4. So we're going to replace that with a 4. But these have the same base. So go back to the very first example I showed you. And when the bases are the same, you keep the base. And what do you do with those exponents? You add them. So 6 plus 4 is 10. We can't add these because the 4 and the x are a different base. But these have the same base, so we can make them stay an x, and then we just add them. 6 plus 4 is 10. So hopefully that makes sense. And then I'll pause and we'll go on to the next section. Okay, now we're going to do the quotient of a power. Quotient means to divide. So you'll notice all of these look like fractions with the division bar in between. So top divided by bottom makes it a quotient, and therefore we're doing quotient of a power. So the bases are the same again. You're going to notice the bases are both 8. So we're going to keep the bases the same. But if you remember back to the very first example, the bases were together and they were next to each other. There wasn't one on top and one on the bottom. When they were next to each other, we added. So now we have one on top and one on the bottom. What do you think we're going to do instead of add? We're going to subtract, okay? So we're going to do 10 minus 4. So I like to write 10 minus 4 so I remember what I'm doing. 10 minus 4 is 6. So we keep the base of 8 and the new power is 6. It's that simple. Same thing here. We have negative 3. That's okay. We learned anytime we have a negative, we keep it wrapped up in the parentheses. And 9 take away 3. 9 take away 3 is 6. So this is what you're doing, but you can just do it in your head. You don't have to write it out, okay? Now this one's a little tricky because it's got two things on top and one thing on the bottom. So let's just look at the top first. That's like the very first example I showed you. The bases are the same. And what would we do with these two exponents when they're next to each other? We're going to add them. So 8 plus 4 is 12. But now we have the 5 to the 7th on the bottom. So we're going to rewrite it with the 5 to the 7 on the bottom. Now we do have we have 2 more bases that are the same. The 5s are still the same. So we're going to keep the base of 5. And what do you think we're going to do with the 12 and the 7 now? One's on top, one's on the bottom. So what do you think we're going to do? We're going to subtract. So 12 take away 7 is going to be 5. 5 to the 5th power. 5 times 5 times 5 times 5, 5 times. Not 5 times 5 is 25. It's going to be a much bigger number than that. So we're just going to leave it like that. I'm going to tilt it down so you can see the last problem. This one's a little tricky because it looks funny, but it's actually really easy. So all we're going to do is we're going to rewrite the problem. 1 times x to the 6th. Well, what's 1 times anything? 1 times 2 is 2. 1 times 3 is 3. 1 times x to the 6th is just x to the 6th. There's nothing special there. So we're going to keep the x to the 6th on the top. And the only thing on the bottom is x to the 4th. So we're just going to take this and put it on the top. We don't need the 1 anymore because 1 times anything is just that thing. So it's extra. We don't need it. So now we have a 6 and a 4. What are we going to do with those exponents? We're going to subtract. So we're going to keep the x the same. And 6 take away 4, 1 on top minus the 1 on the bottom. 6 take away 4 is 2. I'll turn it so you can see. And that's how you do that. And that's pretty much it, guys. That's how you do the first section. So I will give you a couple more that are a little trickier, and then we'll be done. Okay, we only have these 2 questions left, and we are done with the first section. So, and they're pretty easy. This one is going to take the 3, and we're going to put the 3 on both. So it's kind of like what we did a minute ago, where the 3 gets everything, but the 3 is going to go to the x, and the 3 is going to go to the y. We're taking that 3 and we're distributing it and giving it to both things. That's it. Now, we can't do anything further. We can't subtract the exponents because the letters are different. So understand, if you have 2 of the same base, 2 of the same letter, then yes, you can subtract the exponents and you could do 3 take away 3. But if you don't have the same base, you have to stop. X and Y are different. It's like apples and oranges. You cannot put them together. So this is where we're going to stop for this question. Same thing with this one. The 3 is going to go to all 4 things. So there's actually 4 things inside the parenthesis. There's a 4, an x squared, a 5, and a y. And everything's going to get that 3. So the 4 is going to get the 3. The x is going to get the 3. But wait a minute. The x already has a number. It already has an exponent. It has a 2. So what do you think we're going to do with those 2 numbers? Power to a power tells us to multiply. So 2 times 3 is 6. So the x gets a 6. On the bottom, the 3 goes to the 5. And the y also gets the 3. Everything got the 3, but the x already had a 2, so it's 2 times x. 2 times 3, so it was 6. And that's the reason it has a 6. Now, these letters are different, and these bases are different as well, so we can't do anything more than just try to figure out what the numbers are. And at this point, it's kind of up to you. You could just leave it like this, or if you'd like, you could figure out what 4 to the 3rd power is and what 5 to the 3rd power is. But for right now, that's okay. We're just going to leave it like that. You might not have a calculator that does that, and so we're just going to keep it like this, and that'll be fine for the test. Okay? So that wraps up section 5.1. I hope you learned something, and I hope it made sense. If it doesn't, let me know, and I can help you. And everything is due by Friday at noon on Friday. It'd be nice, though, if you could try these every day and, stay up on it. Every day I'll have a video, and then you'll have some questions to answer. So now that you've learned section 5.1, you're going to want to go try the worksheets from 5.1 and just answer those questions. And then, yeah, if you have any questions, let me know, and I will see you tomorrow for 5.2.